Hi guys, welcome to Explore Learning. Today we're going to be talking about a very interesting topic, and that is going to be how to enhance your images, especially where you need to improve the quality of your data set. So the technique we're going to be using today, it's called the contrast limited adaptive histogram equalization. The short name for it is called CLO. Without any further ado, let's begin. Let's go straight to creating a Python script. Image processing 4. Now the reason why I call it image processing 4, if you notice, we've been talking about image processing, the different things we can do, the different manipulation we can carry out on our images. So this is the 4th version of it, and what we're going to be doing today is actually building on what we have done in our previous class. So if you're new to this channel, please check out my other videos. You're going to see what we've done so far. Alright, so let's create a title for this script. Let's call it contrast limited adaptive histogram equalization. Alright, so let's mark that cell down. Mark it down and let's run. Very good. Alright, so the first thing we're going to do is to import the libraries. What's that? Import CV2, import OS, import globe. Create a new cell. Let's read the image. So we need to specify the image path. So don't forget the raw string. Let's get the images. Okay, so this is the images. Let's deal with this images, the car images. So copy the link to the path. Let's go straight to the Jupyter notebook, paste it right here. Now we also need to specify the destination path where we want to save the images. All right, so I've created the folder, so let's take this out. Okay, so I've created the folder new. Okay, copy this path. Okay, so let's go back to the Jupyter notebook, paste it right here. Create a new cell where we're going to be performing the major operation. Alright, so I equal to 1 to 4 img in globe dot globe. We want to return the images in this path. Okay, the file in this path. So we say plus, we put a code / we say asterisk dot asterisk means all of the file or all of the images in that file path. Okay, we put a colon and then we have an inner loop try, and then the exception in case anything goes wrong. We want the script to print a message saying operation not executed. Now let's specify what kind of operation do we want to perform. So the first thing we need to do is to read the images. Let's say image equal to cv2.im read. So let's read the images that we have returned into this variable, and then once we do that, the images is being read into this variable again called image. All right, so the next thing we need to do at this point, since we're performing contrast limited adaptive histogram equalization, this is a technique to improve the quality of your image. It's actually to add brightness to your image. Okay, it's to enhance the visual quality of your image. So the next thing we need to do at this point is we need to convert it to grayscale first. All right, so we've done this in our previous lessons. So let's convert to grayscale. Remember how you convert to grayscale. Okay, so if you can't do this, if you can't remember, check out my previous videos and you're going to see. Of course, I'm going to take you through. Okay, so let's say cv2 dot, we use cvt, which is convert. What we want to convert is the color, so it's going to be capital letter C O R into bracket. All right, so you need to specify which image do you want to convert to grayscale. So it's this image. Okay, so the images that has been saved in this, all the images that has been saved in this variable. Okay, so the next thing we need to specify which color we want to convert the images to. Now don't forget, the images are in color, they're actually in RGB, so we want to convert them into grayscale. All right, so we say cv2 dot, so we use the uppercase color underscore, we say bgr2 gray. Okay, so that will automatically convert the images into grayscale. Okay, so this will be done automatically. All right, so the next stage we need to do is that we need to create the contrast. We need to create a contrast and then apply it on the image. So the first thing we need to do, we need to create the contrast. So we say clo, which is the short name for this. You can use any variable. Okay, so let's say clo, let's just give it a name. So let's say clo equal to cv2 dot, is that a dot? No, dot create. So what are we creating? Let's create the contrast histogram equalization, which is nothing but clo in short. So the next thing we need to do, we need to pass two arguments. The first argument is called the clip limit. All right, so you might be wondering what the clip limit is all about. It's actually the threshold for the contrast limiting. Okay, the threshold, we want to set a threshold value. So you can set any value, you can play around with this value. Okay, so let me set it to 9 comma, and then the other argument we need to pass, it's called the tile grid size. Actually, it's nothing but a kind of m by n tile, a grid, like a matrix, something like that, like a filter, so to say. So we have that. We can say let's play around with 10 comma 10. So this will actually create a filter of 10 by 10, and then what happened is that it divides the input image into this grid size of 10 by 10, and then what it now does, it applies this histogram equalization on each of the local tile. So this is what it does. So after creating this contrast, we need to apply it on the input image. So how do we apply that? We just need to let's create a variable. Let's call it new, let's just say new clotho, right? Let's just call it new clotho, because you can use any variable of your choice. Okay, so all we need to do, this clotho that we have created, okay, this one we have created, so we have it there, and then you say dot apply. Okay, so that is the function. So we want to apply it on the image. So which image do you want to apply it to? We want to apply it to the grayscale image. Now don't forget, when you want to carry out contrast limited adaptive equalization, histogram equalization, you have to convert the images to grayscale first. That is why in our previous lesson I had to teach you how to convert your images into grayscale, because that is the basics for most of the image processing technique. You want to perform maybe other kind of image denoising and all of that, you have to first and foremost convert your images to grayscale. Most of these operations work on grayscale images. Alright, so once we've done that, the next thing we need to do is what we have done before. Alright, so the next thing we need to do first is to specify where we want to save these images by using the chd arrow. Okay, now we want to specify this directory, so we say save the images to this directory, the folder we have created. Alright, so the next thing we need to do at this point, we need to name the images. Okay, let's name it. Okay, so we'll call this let's call it new new file. Let's call it new file underscore. Alright, so since there are more than one, since it's more than one images, so we need to iterate it. Let's attach a string value. Let's attach 1 2 3 4 to it. Okay, so we say str comma I. Alright, so we have set I to be equal to 1. So as the okay, so we need to also specify the image format. We say .png. Alright, so that's done. So we need to write this image. You know, when you write something you're trying to save it to .im write. When you write, you need to specify two arguments. The first one, it's the name of the image you want to save, okay, which also includes the format, and then the next thing is which image you want to save. Now don't forget, it's the new clotho. Alright, the new clotho you want to save. So once that is done, the next thing we need to write this final command. You say I plus equal to 1. So it means once it iterates through the first image, it should continue to the very last image. It shouldn't just stop at the first image. Okay, and then the exception prints an error message if there is any error at the end of the day, so that we can check where the error is actually coming from. So if everything is perfect, so let's run and see. Now we've not gotten any error, it means everything is perfect. So let's check what we have. Let's go. Wow, we can see. Wow, you can see the nature of the image. You can see the name of the file. You can see the image. It means the contrast. We've actually increased the contrast of the image. So it makes the features very visible for deep learning models. So when you want to train your deep learning models, your computer vision models, once you have your images converted to you have contrast applied on it, you can actually use these images to train your neural network. What it does that it helps the neural network to learn more features. Okay, now you can see the features of the car are all visible, you can see. So all right, thank you so much for being part of this lecture session. Don't forget to share, don't forget to like, and don't forget to subscribe if you're new to this channel. All right, and also I'm going to include the link to the GitHub where you can find this code. Goodbye.